Well, we've made it to our last video for the chapter. So we're going to work a little bit more on rationalizing the denominator. You can see these problems look a little bit more complicated than what we've seen before, but that's all right. So in this example, we see that we are dividing by a radical, that square root. So to rationalize that, if you remember, we multiply the top and the bottom by the square root of 3. So what makes this one different is the numerator of our fraction has two terms. So that means we're going to multiply them both by the square root of 3. It's going to work like distributing. So square root of 21 times the square root of 3, those are both radicals, so we can go ahead and multiply the numbers. We get the square root of 63 plus, now we're going to distribute to the 15, that gives a square root of 45. And then if you remember, the square root of 3 times the square root of 3 is just 3. So, is this simplified all the way? Is this our final answer? Well, we have an addition problem with radicals, and basically anytime you have radicals, you do want to think about if you can reduce those. So I'm going to kind of reduce off to the side. Square root of 63, you can break down into a 9 times 7, which turns into a 3 square roots of 7. Here, I'll rewrite this down here. We have 3 square roots of 7 plus... Now 45, can we break that down? Well, that's a square root of 9 times the square root of 5. Square root of 9 is 3, and the square root of 5 is 5, all over 3. All right, so can we do the addition between the two radicals? Well, they're not like terms, so no, we cannot. But what you may notice is we have a 3, and a 3 here. So here's the math of what you can do. In the numerator, if you look at just these two, they have a common factor of 3. So we can factor a 3 out, leaving you with the square root of 7 plus the square root of 5. If you think about that, could be distributed back in to give you those terms. And this is over 3. And now that that 3 is on the outside, we can go ahead and reduce it with the 3 in the denominator, so they cancel each other out. And our final answer is just the square root of 7 plus the square root of 5. So another thing that you could do, kind of to shortcut that, but that's the math of why we can go from this answer to this answer. If you notice that every single term of your fraction has a common factor, you can go ahead and divide them all by 3 and get to that same answer. But it only works if you can divide everything by the same value. Alright, next example. Same idea, we're going to rationalize this. Multiply the top and bottom by the square root of 2 so we can get rid of that radical in the denominator. I'm throwing parentheses around the numerator so that I can see that as distributing. So we go ahead and multiply this in. That gives us the square root of 12 minus the square root of 48 over 2. Alright, can we reduce the square root of 12? That breaks down into 4 and 3. I'm going to write that answer down here. We have a 2 square root of 3 minus. Now this actually breaks down into 16 and 3, which is 4 square roots of 3 all over 2. Now in this one we do have like terms up here, so we can go ahead and do that subtraction. 2 minus 4 is negative 2, and the square root of 3 stays all over 2. And now we can reduce these outside numbers. Negative 2 divided by 2 is negative 1 square roots of 3. That's the same thing as a negative square root of 3. So either one of these I would take as your final answer.